Welcome to MKE Gadgets. Today we're going to do something different. I was recently given this bracket, and this is for a 41 Ford pickup truck taillight. Now back in 41, you only needed one taillight and they had no turn signals. So the owner of this truck who's restoring it needs another bracket made. And this bracket is 77 years old. It was stamped out of steel. So in order to recreate this bracket, I have to do reverse engineering. This is a pretty easy part. I'm not going to do the bending it. I'm going to let him do that. The owner of the truck has a torch and he can easily heat this up and bend it or keep it straight. What's important is the relationship of these two holes to each other, because this goes onto the bed of the pickup truck. This holds the light, and these two holes to each other. Now you got a lot of leeway in here in making that. So the first thing I did with my die grinder off camera, I used this kind of like a Scotch-Brite wheel to remove the rust. I didn't want to remove any material or throw any sparks, so it's kind of rusty. I didn't want to use an abrasive wheel because I didn't want to remove material. So I removed the rust and put masking tape on. And with a hobby knife, I traced around all the holes and the profile. Because what I need is a flat pattern with this bend in there so I can make it as accurate as possible. If you're going to do this, get the widest tape possible. The first one I used inch wide tape, and that was kind of a pain because you had to use a bunch of pieces. And when you peel it off, it kept tearing on the seam of the tape. So what I did is remove the tape and I laid it out as flat as I could. And then I started taking my measurements because you have to make a CAD model for this. And I figured out how wide it was, the center distance from hole to hole, what size the holes were. So I used my gauge pin set and I found out that these three holes are 290 thousandths in diameter and the big hole is 362 thousandths. So I used all of the information. I made a drawing and I dimensioned the best I could. The next thing I did is I took all this information, sizes, radiuses, distance, and I made a CAD file. With the CAD file, I took it to my mill. So once I had the flat pattern, I could figure out what size material I needed. I'm using 836 steel, 3/16 thick, 3.5 by 5.5, and it cost me $2.75 each for the steel. I bought it at a place called speedymetal.com. So I made one, and you can see the holes line up real well. These holes line up real well, and these holes line up real well. So the first thing I want to do is take this hunk of steel over to the mill and drill all the holes. Once I have the holes drilled, I can bolt this down to a flat plate and mill the profile. So let's go over to the mill and start drilling. We're at the Bridgeport mill. Here's my piece of steel. I have 3 dowel pins set up here to hold the part from rotating. As I tighten it up, I push the stock into the 3 pins. So this corner of the part right here, I set up my X and Y 0. With the number 3 center drill, I'm going to center drill the 4 holes. With all 4 holes drilled, I'm going to change the center drill to a 1/4 inch drill. When I drilled the holes for the first part I made, I drilled all the way through the part and into this piece of aluminum. This is my fixture plate. I did that with a number 7 drill because the number 7 drill is the drill size for a 1/4 20 tap. I tapped it 1/4 20, and I'm using 1/4 20 flathead cap screws. And the idea is here, with the flathead cap screw, the taper, that's a 82-degree taper, the screw will fit into the hole and center the hole on these 4 threaded holes. Gauge pins have been removed because I'm going to mill the profile, and the gauge pins would just be in the way. So now I'm going to thread the bolts into the 4 holes and tighten it down. So the plate's bolted down with 4 flathead cap screws. It's nice and tight. You don't want it to move or rotate on you. I'm going to mill the profile with a high-speed steel 1/2 inch 4-flute end mill. Now we're going to cut some chips. So we got 10 thousandths to go on this. This piece is going to lift up. So I'm going to push it down with a piece of angle iron. These air pieces shouldn't be a problem. Just as the end mill was finishing the profile, I'm not sure if the battery died first or my SD card was full, but I missed that. I put my battery pack on and I cleaned out my drive and I should be ready to go. So with the being completed mill, you just remove these screws. And here's the finished part. Yeah, it's got some burrs on there. So I'll deburr that and we'll go over to the bench. Well, the 2 brackets turned out pretty nice. All I gotta do is drop them in the mail and get them out to some guy I know who is restoring a 41 Ford pickup truck. Please subscribe or tell your friends. Thank you for watching. I hope you enjoyed this. So this is called reverse engineering. You take a part that already exists with no drawings, no model. You make a template, make a CAD model, and then you machine the part. For all my family and friends who wonder what I do at work and in my shop, this is it. A little bit of machining.